Chapter 10, number 38. A. Calculate the magnitude of the angular momentum of the Earth in a circular orbit around the Sun. Before I go over that, what the questions are, I'll go over a few things. So we have our angular momentum, which is equal to length, which is equal to inertia times angular velocity. Our moment of inertia, which is I. Angular speed, basically it's all this stuff. So also angular speed is equal to velocity over radius. We have a linear velocity or radius. Angular momentum is equal to length, which is equal to, angular momentum is L equals I times V over R. So for A, we have the mass of the Earth, which is 5.97 times 10 to the 24th kilograms. So the radius of the Earth is 1.5 times 10 to the 4th meters. 10 to the 11th. 10 to the 11th meters, and the Earth's speed or velocity is equal to 2.98 times 10 to the 4th meters per second. So we get that our angular momentum is equal to mass times r squared, or our inertia times velocity over radius. So end up with mass times radius times velocity, and when we plug in the numbers, we end up with 2.67 times 10 to the 40th kilograms meters squared per second. So for B, the question is calculate the magnitude of the angular momentum of the Earth due to its rotation around an axis through the north and south poles, modeling it as a uniform sphere. So we have the equation for a solid sphere is inertia is equal to 2/5 times mass times radius squared. Radius of the Earth, again, is 6.38 times 10 to the 6 meters. We have our angular velocity, or angular spin of the Earth, which is 2 pi over t, and t is 24 hours, and we can break that down to seconds, so it's 24 times 3600 seconds for our angular spin of the Earth. So then we can plug it in for our angular momentum. We have angular momentum is equal to 2/5 times our inertia, is equal to 2/5 times 5.97 times 10 to the 24th times 6.38 times 10 to the 6 times our angular spin of the Earth, which gives us 7.06 times 10 to the 33rd kilograms per meter squared per second.